All right, so now we have incorporated our third and final conversion factor into our mole concept. 1 mole of a gas at standard temperature and pressure is equal to 22.4 liters. That is our third conversion factor. Keep in mind when you are working these problems that you should be looking at your reference sheet that has all 4 of your conversion factors. So I'm going to go ahead and do question number 6 here. I'll begin with my dimensional analysis setup. This question is asking me for mass. So my unit for mass is grams, and it's asking me for the mass of oxygen gas. We know that oxygen gas is one of our 7 diatomic elements, so it is a molecule with a formula of O2. All right, so then my next question is my starting point, and that is my given 38,000 centimeters cubed of oxygen gas. All right, so next thing I want to do is take a look at my conversion factors and pick out what conversion factors I need. Again, I'm looking for keywords. So the first keyword I see here is mass. Mass tells me that I need the number 2 conversion factor, which is molar mass. So I'm going to go ahead and write out that molar mass conversion factor. I'll scribble that out just to avoid any confusion. 1 mole of oxygen gas is equal to 32 grams of oxygen gas. Where does that 32 come from? If I look on the periodic table, I see that oxygen has an atomic mass of 15.99 or so. I'll round that to 16. And then I will multiply that by 2 because there are 2 oxygen atoms in 1 molecule of oxygen gas. So that's where 32 grams come from. All right, so that's my second conversion factor. I'm going to need that, or conversion factor number 2. I'm going to look for some other keywords here, and I see centimeters cubed. Centimeters cubed is a unit of volume, so I need the third conversion factor, 1 mole of a gas, in this case oxygen gas, as long as it is at standard temperature and pressure, which we see here in our problem, is equal to 22.4 liters of oxygen gas. So I am going to need these 2 conversion factors, conversion factor number 2, the molar mass conversion factor, and conversion factor number 3, the Avogadro's law conversion factor, to solve this problem. But when I look at my starting point, I have centimeters cubed. I can't plug either one of these in here, so I'm going to have to get from centimeters cubed to liters. So I will begin that process now, and I know that 1 centimeter cubed is equal to 1 milliliter, and that's of oxygen gas. And this just goes back to what we learned in the metric system. All right, and then there are 1,000 milliliters of oxygen gas in 1 liter of oxygen gas. Now you could just say that there's 1,000 centimeters cubed in 1 liter of oxygen gas. That would work as well. All right, so now I'm in liters, and now I can plug in this conversion factor. So now there is 22.4 liters of O2 in 1 mole of O2. And I plugged it in just the way that it is because I've got liters right here. I want liters down here so that they can cancel out. And then I will plug in my final conversion factor, moles, here. So I'm going to flip this conversion factor over so moles is on the bottom. 1 mole of O2 is equal to 32 grams of O2. Now it's time to go to the calculator. Go ahead and multiply 38,000 times 1 times 1 times 1 times 32, and then divide that by 1,000. Then divide that by 22.4 liters. And that gives me 54.3 grams of oxygen gas in 38,000 centimeters cubed of oxygen gas.